Warning, proximity alert.
Hey there. Um, so before I start this video, I just want to give you give it like a legal disclaimer, if you can call it legal. Really, I'm not a mathematician. I actually have pretty standard fundamental math education. However, much of what I do um, with math comes basically from an attraction and curiosity of patterns. In most cases, I look for patterns in math and slowly engineer the answer. It's like a type of reverse engineering. One thing I like to do is play with numbers. It's what I call a number discovery, and to me, it's just simply fascinating, and I could not explain to you why. I have this particular, at least to me, it's an anomaly. It's been in the back of my head for a few years, and I come back to it from time to time and think of the possibilities of utilizing this particular algorithm as another type of trapdoor function. And if you don't know what trapdoor function is in math, it's described as something that's sort of, it's easy to compute one way, but difficult, very hard to sort of compute that in the reverse direction. And they use that with in RSA, public-private key encryption with prime numbers and semi-primes. Um, you can look that up. It's a quick Google away. So I'm not saying that this particular thing is impossible. Um, I'm not quite sure why it does what it does. It's so simple, but I'm not clear on the mechanics of what it does, and hopefully somebody can give me an answer. And it's likely going to be math easy solutions. He's obviously a math genius, and perhaps he can take a look at this and try to explain to me what in the world is why this does what it does. So it's fairly simple, and I'll show you. So kind of pick any number and um, any number you like, and what I'm just going to quickly do it here, and when I'm done, I'll show you the anomaly. Um, so that's kind of it right there. That is the algorithm. I just kind of mod things, and in the end, I get this sort of seemingly random set of numbers. On this side is really where it begins. So what I'm doing is I'm adding this number can almost be anything. It does curious thing. So what I'm doing is I'm taking this value and I do a modulus against it, and I get the remainder. And then what I do is I add that remainder to the whole number again from the previous mod. And of course this builds up and builds up. But these numbers seem random. But if you look at the total of these numbers, they're always the same sum of the starting value.
It is not logical.
So if I do this, take the sum of all this row, and I change this number, there is a I'll explain that 3 in a minute, at least from my analysis of what's going on there. See, no matter what number I choose, it'll end up always being the 123. Now if we go back to the 3, it's just because this particular number is divisible by the 3. And really, in reality, if you add all these 3's up to the end, you'll end up getting 123. So it works with numbers that are not divisible directly into the value. So something like a prime would be interesting to use. Eventually you'll get conditions on this end where as the number is sort of deduced and deduced keeps going down, you'll hit the a factor of that. Anyways, I thought this would be cool to share. I thought it was an interesting and neat little discovery. So if you have an answer to why this does what it does, post, let me know. Thanks.